Hello, dear students. How are you doing today? Today's lesson it will be about functions lesson on lesson 1 on page 52 and till 55. Okay, student. So before we know what is the functions, we have to know the relation, okay? So a relation shows a relationship between two values. A function is a relation where each input has only one output. Okay, so for example, we have here functions and here it is not functions. Okay, so function must be like 1 to 3 and 2 to 4, 3 to 5, 4 to 5, 1 to 1, okay, or many to 1. We call it function. But if 1 to many or many to many, they are not a function. I think it's kind of a little bit complicated, but by solving and explaining exercises and examples, you will learn a lot of functions that how we solve them. Okay, so we have here. Suppose the weight of 4 students are showing in the following table. Here it is our table. So there are students. One of them has a weight of 120, and the second one 100, and the third one 150, and the fourth one is 130. The pairing of the student number and his corresponding weight is a relation, okay, and can be written as a set of ordered pair numbers. Let's say weight equal 1, 122 to 103 to 150, and 4 to 130. The set of all first elements is called the domain, okay, of the relation. The domain of weight is equal 1, 2, 3, 4. We call it domain, okay. The set of second elements is called the range of the relation. Okay, now we have the range 120, 100, and 150 and 130. We call these numbers range, and the first 1, 2, 3, 4 are domain. So the definition of function, so student, when we talk about that, like any topic, okay, you have to know what the meaning of that topic, not just solve them, by numbers and that's it, okay. No, you have to know the meaning of that subject. Let's say what is function, okay. So a function is a relation in which no two ordered pairs have the same first element. A function associates each element in its domain with one and only one element in its range. Must be with one and only one element in its range. So we have here example. Determine whether the following are functions. We have here A, 1 to 2, 2 to 3, 3 to 4, 4 to 5. And B is 1 to 3, 0 to 3, 2 to 1, 4 to 2. And C we have 1 to 6, 2 to 5, 1 to 9, and 4 to 3. So here is the solution. A, 1 to 2, which is till 4 to 5, is a function. Why it is a function? Because all the first elements are different. The first element, that means this one, okay? These are different, must be a different. So B is a function because all the first elements are different. The second element does not need to be unique. Okay, so we have here 1 and 0 and also 2, they are very different from each other. So we have C, 1 to 6, 2 to 1, 1 to 9, 4 to 3 is not a function. Why? Because the first element, number 1, is repeated. Okay, the first element must be not repeated. Okay, so as they are repeated, they are not a function. A function can be identified from a graph. If any vertical line drawn through the graph cuts the graph at more than one point, then the relation is not a function, it's called the vertical line test. Okay, student, now you know the first element must be a different. Okay, here, if they are having the same number, they are not a function. So we have here function notation. F of x equals 3x plus 1. Okay, this x we called input domain. Okay, we put it here and then we put it here to solve that equation. Okay, name of function f of x. We call it the name of function is f of x. Now and on, you will say f of x or f of y, f of z, or whatever the letter is. Okay, let's say f of x because we use it more than any other letters. So here this x is input domain, and here it is output range. For example, here f of x equals 3. We will put 2 here. Why? Because it is x. Okay, so it equals to 7. The same thing if we put it for x negative 4, it will be like 3 times negative 4 plus 1 equals 11. So here we have another definition of function. A function is a mathematical process that uniquely relates the value of one variable to the value of one or more other variables. So we have here function y equals f of x. Input variable is x and output variable is y. For example, we have sine output and x input, cosine output and x input, and exponential output. We have x, they are input. Okay, input. So here it is our example, and this is the definition of a function. So here it is our example. We have an independent variable, which is x, or dependent variable is y. So we have table A and also table B. The question is, state whether the data in each table represent the function and explain. So we have table A. For each value of x in the table, there is exactly one value of y. The data set is represent a function. Okay, so B, the data set does not represent a function. Why? Because 3 different y values r and 10 are paired with 1x values 3. So we have here 3, 3, 3. So we have here repeated numbers, so it's not a function. We doesn't have any repeated numbers, so it is the function. Okay, example 2. State whether the graph represents a function. Explain. So we have the graph. Okay, here. The solution says the graph does not represent the function, since any vertical line to the right of the y-axis cuts the graph into points as shown. So we have here 2 points here, as it is cut the y to 2 points. That way it is not a function. Okay, student, this was the end of our lesson, and good luck.